Okay, but I did make your skeleton notes. So, there you go. There you go. There you go. There you go. Well, skeletons are like the bones that you fill in all the guts. Right?
Yeah.
I mean,
That's the
you
best
could live
part.
with bones and no, but not without guts. Couldn't live with guts and no bones.
The guts are
Put it
the
on
best
together.
part. They're so slimy.
So basically, I'm saving you guts. Okay. So, as you see on the top, that says theoretical and experimental probability. Okay, our objective here okay, is that better? Okay, don't be sleeping. Okay, theoretical and experimental probability. Okay, and this is 2, 24, 22. Okay, did you know that's a palindrome too? Look at it.
What's it power?
2, 2, 4, 2, 2. If you read it backwards, it's 2, 2, 4, 2, 2.
No, it'd be 4-2. Not mine.
But look, 2, 2, 4, 2, 2, 2, 2, 4, 2, 2.
Did we not race car as a palindrome?
And so is Taco Cat. Taco Cat's the most famous palindrome. Okay. Taco Cat forward is the same as backwards as Taco Cat. You know, not cat tacos. Those are gross.
So is Hannah.
So is mom and wow and dad and poop. Okay, all right. Sorry. Let's get started with this stuff. Okay, theoretical versus experimental. Okay, do you understand the objective of this is to determine and compare. This is the objective. Determine and compare theoretical and experimental, forgot the X, experimental probabilities. Okay, so let's start with some definitions. Theoretical probability. Okay, write this on your skeleton notes. Theoretical probability is what is supposed to happen.
What?
Write that down.
For this
What is supposed to happen? Theoretical probability is what is supposed to happen. Okay? Theoretical probability. What is supposed to happen? So, if I am flipping a coin, every time I flip a coin, what is the probability I'm going to get a heads?
50%.
50%, 1 out of 2. Every time. That's theoretical probability. What is supposed to happen? If I roll a number cube, 6 heads, what's the probability I'm going to get a 3?
25.
How many 3s are there?
15.
1 out of how many? 6. 1 out of 6, which is about a 16% chance. Okay? If I have a die that's numbered 1 through 20, okay, what is the probability theoretical probability that I'm going to get a 5? 1 out of 20, okay, or 5%. Does that make sense? Okay, it's the theoretical, bless you, all of the probability that we did yesterday was all theoretical, okay? Experimental probability. Based on results. Based on results. So let's say I flip a coin 10 times, and 8 of them are tails. That's 80%, right? If I said the experimental probability that I'm going to get tails on the next one is 80%. Is that true?
Maybe.
If it's based on experimental probability, yes. Okay? If I'm basing it on theoretical probability, it's not true, is it? Bless you. Yeah, that was cute. Don't do that anymore. All right. Make sense? Yes? Okay. So let's look at, if you look at example 1 on your notes. Okay, read that for me, somebody.
I will.
Okay?
Okay. Kawan is conducting an experiment to find the probability of getting 0, 1, 2, or 3 heads when tossing 3 coins on the floor. The result of this experiment are given at the right.
Okay, so what he does, takes 3 coins and he throws them on the floor, okay? And he's trying to see how many times he gets heads, okay? If you notice, how many times did he get 0 heads? Look at the graph.
3 times.
How many times did he get 0 heads? 3 times. How many times did he get 1 head?
8.
8. So let's start thinking of something. That was 3 tosses. How many was that? 8. How many times did he get 2 heads?
9.
9. And how many times did he get 2?
Plus 3.
How many times did he get 3 heads?
3.
2. Okay, so let's add all these together. 3 plus 8 is?
11.
11 plus 9?
20.
And 20 plus 2?
22.
Okay, so he did this 22 times. Okay, that's going to be important, isn't it? That's going to be important. Hello. There you go. Thanks. Okay, so what this says, first of all, we're going to base this on the results of what we did, right? So based on the results in the bar graph, what is the probability of getting 3 heads on the next toss? How many times did he get 3 heads? Look at it. 2. Out of how many?
Out of 22.
Out of 22. So that would be a 1 out of 11. Or if you were to figure out that percentage, somebody with a calculator, I'll figure out what that percent is. Anybody?
What would you do to figure out
Wouldn't
the
it be just
percent?
22%?
Divide the top by the bottom?
Wouldn't it be 22%?
No, not quite. It would be, if you divide 1 by 11, it's, okay, my calculator's done. It doesn't work right. Okay, it's about a 9%, 0.09, so it's about a 9% chance. Okay? Does that make sense where that came from? Does that make sense where that came from? Okay, let's look at the second one. Based on the experimental probability, how many times should Kuwan expect to get 3 heads in the next 55 tosses? Okay, now let me show you how this is set up. You guys are, we want to know how many times he gets 3 heads if he tosses, if he does that 3 coins 55 times. Okay, so we're going to set up a proportion. Good job, way to say should. Okay, proportion. So we already know that 1 out of every 11 he gets 3 heads, right? Right?
Right.
We want to know how many, if he did this 55 times, what would this be? Well, this is easy, right? Right? 11 times what is 55?
5.
5. So what's 1 times 5? So if he does this 55 times, he should expect to get 3 heads. How many times? 5 times. Okay? Does this make sense so far? Okay. And let's look at that last example. Okay, suppose, what is the theoretical probability of getting 3 heads on a toss? Okay, well, let's first of all think about if I toss 3 coins, okay? What are all the possibilities that I have here? Anybody? What can I get?
3 heads.
Okay, I can get 3 tails. What else could I get? Could I get a tails, heads, tails? Could I get a heads, heads, tails? What else could I get? I could get heads, heads, heads. What else could I get? I could get heads, tails, tails. What else? Heads, heads, tail. Oh, I already have that one, sorry. Okay, I'm just going to save you some time. There are 8 possibilities. How many of them are heads, heads, heads? 1 out of 8. Okay? Save you some time. Okay. All right, let's look at the next example, okay? You see the next example on your sheet? Okay, let's take a look at that one, okay? We're going to use this table to the right that shows, now, the first thing that we have to think about, okay, just like with regular theoretical probability, we have to think of how many possible outcomes there are, okay? This is based on how, this is experimental, this is based on how many times we did it. So what does that say? Use the table that shows the results of spinning a game spinner how many times? 50 times. Based on the results in the table, does that say based on theoretical? No, based on the results in the table, what is the probability of spinning a green? How many greens are there?
There are
18.
18 out of how many?
18 out of
out of 50, which we could reduce to 9 out of 25, which if we were to write as a percent, what would that be? 36%. Oh, sorry. This should be up here.
9 out of 25?
18 out of 50 equals 9 out of 25 equals 36%. Okay? Do you understand where that came from?
Yes.
Okay? So let's look at, this is actually pretty easy. Based on the results, how many greens would we expect in 300 spins? So again, we're going to set up a what?
Proportion.
A proportion. We're going to set up a proportion, okay? So this is going to be, well, we already know that we get 18 out of 50, or we could have used 9 out of 25. This is 18 out of 50 total spins. How many total spins am I talking about here? 300. So that 300 is going to go down here. And I'm going to find this. Well, what's 50 times what gives me 300?
6.
6. So what's 18 times 6? What's 10 times 6?
60.
60. What's 8 times 6?
48.
What's 60 plus 48?
148.
108. Okay, so we would expect 108 of them, not percent, 108 of them to be green. Okay, does that make sense? Okay, fill that in on your sheet. Okay, number 3, what is the theoretical probability of spinning a green? So, is theoretical based on results? What is theoretical based on?
It's based on...
What is supposed to happen, right?
Yeah.
So let's look at this. How many of these are green?
Not a lot. 2.
There are 2, but we need to be careful here. Why? Look at that thing. How many spots are there? There's 4, right? There's red, green, green, and blue. But if I did 2 out of the 4, does it look like 50% of that is green?
No.
No. What do I have to take into account here?
The blue.
I got to take into account that these are not all evenly spaced, are they? Okay. If I did this, these are both what?
Red.
Red. Okay. So how many of these are green?
2.
2 out of how many?
2 out of 6.
2 out of 6. Okay. Which is basically 1 out of 3, which is what? About a 33% chance of landing on a green. Okay. Does that make sense?
Yes.
Okay. Is it close to the experimental probability? What was our experimental probability of getting a green? 36%. It was close, wasn't it? Okay. Now, if I did this 300 times on theoretical, okay, how many would I expect out of 300 spins? Now, the easier one of these is 2 out of 6 or 1 out of 3 to get to 300. Let's do 1 out of 3. Okay, 3 times what is 300? 3 times what is 300? 100. So 1 times 100 would be what?
100.
So we would expect 100 of those. Okay, and then when we experiment, or when we compare those theoretical to experimental, there's about a 3% difference. Okay, this is easy stuff, isn't it? I'm sorry I had to go fast.